Theoretical recap. Secure scripting best practices are not optional additions, they are the foundation of any professional automation script, especially in a security context. When you write a Python script intended for security tasks, several non-negotiable rules apply. First, the shebang line, #!/user/bin/nem python3, ensures your script runs with the correct interpreter regardless of the system environment. Second, file permissions must be set correctly. A script that handles sensitive data should never be world-readable or world-writable. Use chmod 700 or 750 as a baseline. Third, secrets, API keys, passwords, tokens, must never be hard-coded in the source code. They belong in environment variables or dedicated secret management systems. Fourth, your script should handle errors gracefully using try/except blocks and provide meaningful output rather than raw tracebacks. A common mistake beginners make is writing functional code first and treating security hygiene as an afterthought. In professional environments, this mindset creates vulnerabilities that are exploited at the scripting layer itself. Mental model. Think of your script as a small application exposed to a hostile environment. Every input is untrusted, every secret is a liability if exposed, and every permission is a potential attack surface. Example: a scanner script that prints hello, username, fetched from an environment variable is already safer than one that hardcodes the username or reads it from an unprotected config file. Workshop brief. In this workshop, you will take a deliberately poorly written Python script called hello.py and transform it into a hardened, production-ready script that complies with all the secure scripting best practices covered in your most recent lesson. This is not a theoretical exercise. You will produce a working, auditable Python file that you could present in a professional security portfolio or code review. The starting version of hello.py performs a simple but realistic task. It greets a user by name, logs the greeting with a timestamp, drawing on your earlier work with dates and timestamps, and outputs the result in a chosen format, plain text, CSV, or JSON, building on your output format lesson. However, the original file has been written carelessly. It contains a hard-coded username and a hard-coded API token used to simulate authentication. It has no shebang line, it runs with overly permissive file permissions, it lacks any error handling, and its output leaks sensitive information. Your job is to identify all of these issues and correct them systematically. Steps to follow. Begin by reading the provided hello.py file carefully and listing every violation of secure scripting best practices you can identify. Do not fix anything yet. Write your audit observations first, either as comments in a separate file or as a short written note. This analytical step is essential and will be part of your submission. Think about: what data is hard-coded? What happens if the script is run by the wrong user? What does the output reveal that it should not? Once your audit is complete, apply corrections in a structured order. Start with the shebang line and file permissions, then move to secret management, replace hard-coded values with environment variable reads using as.environ.get with safe fallback handling, then add proper error handling around all I/O operations and external calls, and finally review the output to ensure no sensitive data is leaked in any of the 3 supported formats: text, CSV, JSON. Each fix should be intentional and traceable. Leave a brief inline comment explaining why each change was made, not just what was changed. After hardening the script, write a short validation checklist, 5 to 10 points, confirming that each best practice has been applied. Run the script in at least 2 scenarios, once with the environment variables correctly set, and once without them, to verify that your error handling behaves safely and informatively. Capture the terminal output of both runs and include it in your submission. Finally, reflect briefly, 10 to 15 lines, on what the consequences would have been in a real production environment if the original hello.py had been deployed as is. Consider the context of a penetration tester or a DevSecOps engineer discovering this script on a compromised system. This reflection demonstrates your ability to think offensively and defensively at the same time, a core skill for the cybersecurity and DevSecOps profile you're building toward.